This talk is about how you can guarantee that no one understands what you did in your machine learning project. So it's a bit of a cheeky take on what not to do. And kind of, yeah, I'll tell you about the things that I use in my work as well to kind of communicate these kind of models. I work with deep neural networks, so the very uninterpretable networks all the time. Like, I've done my PhD in it, I've worked in the last company in it, and I'm working in this company with this technology. So yeah, I really have to learn how to communicate these projects. So why do we do it? Well, we have these awesome projects, right? We work on these really cool things, and we put a lot of brain power into them, and they're awesome. So the problem really is that we get really bogged down in these details, and it's kind of like a mechanic in a shop. You get really excited about the car that you're working on, but no one understands what you're talking about. And you still have to communicate your results to stakeholders, to your colleagues, to everyone else in your company or in your university. You have to be able to talk at conferences as well. So really, communication is super important. And that's kind of why I also got my current job. So I work in numerical weather prediction, and I have no background in numerical weather prediction. I am a geophysicist by background. I used to work with seismic data, and I basically got that job because I could show to them that I'm good at communicating these machine learning results to people that have no real idea what machine learning actually can do. And I think it's a really important skill. And when I wrote about it, like I write online, people were commenting on it. I had like one general manager from Dell comment on my post, essentially saying, yeah, this is really important. The other one is operationalizing machine learning. This is not this talk, but yeah, that's the motivation. I think it's really important, and I think it can really set apart our projects, put them in the right light, and yeah, get ahead in our careers. As an outline, basically I want to talk about communication first, then look into ethics, because surprise, it's really important. And then we'll go into explainability. And well, in explainability, I'll also talk about interpretability and causality, because in my head, they kind of belong in the same area of topics. And yeah, then go into data visualization, because it's really, really good for making things understood. And then talk about interactivity. Finally, some model validation, and then I have some conclusions in the end, of course. So we need to be able to understand how people understand things to be able to work against it. This talk is about making everyone not understand what you're doing. So how do people understand things? They understand your language. So essentially, if you use more jargon, people will understand less. So think back when you were trying to understand machine learning or data science for that matter. When people were talking about the train test split, you were wondering if they were talking about an actual train or about training data and were just using it funny. And yeah, if you simply just talk about train data, it's going to be quite confusing. Like, most people will understand you in the machine learning community, but actual people in the real world will have struggles with this. Like, I'm not even kidding on this one. So be aware how you frame something. And then people really understand things by relating to things they already know. So in my case, with these people in weather, they are really good in statistics in many cases. So they have worked with probabilities and probabilistic predictions a lot, and they know a lot about physical inversion. So being able to relate my machine learning projects to their physical inversion is really valuable, because they immediately go like, oh yeah, I understand this because this is like this. So it's really helping in getting your point across when you can relate to things people already know. And you don't have to be like super specific. It helps. And of course, this comes down to empathy and also to preparing for these kind of meetings. Like, who are you talking to and what expertise do they have? So where can you kind of hook in your machine learning to be able to explain it to them? Then people need to feel heard. In a lot of these meetings I have with domain expert, with subject matter experts, I'm going to use them interchangeably. It's really important to be quiet. So oftentimes you have to leave people room to digest what you're saying, of course, but also leave them room to speak, leave them room to ask questions. So when you can adequately, like, I really recommend anyways to almost to anyone to read about communication, how to be an active listener, and yeah, mirror their question back to them, and then try to answer the question in the best possible way. And if people feel heard, they're much more likely to trust you. Especially they're going to trust your expertise as well, because you are able to like empathize with them. And then have their concerns addressed. So this one is essentially going further into these questions. When people think about machine learning, they have heard about black boxes. And I mean, I know I'm not the younger generation anymore. I'm still struggling with that. But there are a lot of like older folks that you're working with. These people have seen AI before. They have heard the claims in the 80s, 80s and 90s, and they've seen the last AI winter. They heard the promises of expert machines, expert systems. They heard about Lisp and all these things. And also how bad neural networks performed back in the day. So addressing those concerns and being very open about, yes, but we have made all these changes and we have these bigger computers, better data sets. So really going and talking about their concerns, not dismissing them, is really important to, to have people feel understood and to have them understand what you're saying. So obviously we need to work against that, to have them not understand what your machine learning project is about. So how do we do this? Well, we communicate like a proper pro. You ignore subject matter expertise. So for example, when I worked with people in space, I did a lot of like modeling with satellite data, and that meant that you definitely need to ignore anything they say about like the bands and hyperspectral imaging and all the information they have about like the locality where you're actually doing your study. Like, dismiss it. That is the best way to communicate like a pro. Then you want to dismiss existing solutions. It's really important. Like, if people work decades on a solution and have really refined the process, just swoop in with your machine learning solution and say, yeah, this is going to replace everything with just one model, because it's super easy, of course, to replace like decades of work with just one neural network. So really, being dismissive is an art form there, and you have to be really, really well self-aggrandized and very sure to just say, yeah, I know it better. Then absolutely no need to build trust. You just want to like get into the meeting, just be like, this is my solution, this is the accuracy, and just, yeah, basically finish up, pack your lunchbox and be out again. Then never set expectations. machine learning is magic, essentially, right? And everyone intuitively understands what you're doing. So setting expectations is really counterproductive to having them not understand your machine learning model. So any kind of limitations, any kind of time constraints, data constraints, constraints in computation, you really do not want to talk about, because that might mean that people actually understand what you did. And this is especially true, and I had this in multiple situations. You don't want to set expectations about labeling. Turns out labeling is one of the most important things you do in supervised learning. Your data somehow needs an y to the x. So if you do your machine learning modeling, you need some kind of target variable. And getting these labels is oftentimes really time consuming and sometimes even expensive, oftentimes actually expensive. So talking with stakeholders and project managers about this is going to be very counterproductive to being not understood. Yeah, so these are communication tips that you should definitely follow if you want to be misheard. Then next, I think, oh yeah, also there's a bonus for condescension. If you're being condescending because you just finished your machine learning bootcamp, you know better than anyone that has worked in this field. That is really, really valuable. If you can be condescending about your work, that's the cherry on top. And yeah, next, let's have a look at ethical considerations. Because if you go into any subject matter, these people have been working in there for a long time. And I know computer scientists, and I'm a physicist by background, so me neither, haven't really done any social studies. Some people actually look down on social studies. It's a thing, unfortunately. And that means we don't really understand ethics that well. We kind of know it exists, and it's old philosophers that kind of thought about things, and today also social justice warriors that kind of do these things. But if you go into a field like medicine, that's why I put a picture of a doctor pointing at things, which is convenient. This doctor has worked in this field for decades, probably, and knows about all these ethical concerns, knows what is being done to basically, yeah, to work with any kind of ethical considerations. So here are some of the evergreens that you have. Like privacy concerns. This is especially true in medical. You want properly anonymized data, and you want to be careful that your machine learning model doesn't use any protected classes, for example, because this can really get you in hot water, especially in healthcare. You may have heard that DeepMind basically left healthcare because turns out it's really hard. Like, not just the machine learning problem, that one is kind of solvable, like especially if you go into X-ray, those are kind of solvable in a way. But working with healthcare and working with regulations is in healthcare is probably one of the hardest things you can do. So yeah, working around in the US, it's you have these everywhere. But it's not just medical. So for example, in satellite data, oftentimes you can combine different data sources. So think about if you have satellite data and you have energy consumption data, if you are not careful about only using aggregate data in that energy consumption, you can have some very specific knowledge about what people do at what times, because you can essentially have their locality from satellite data and then combine that with other data sources to circumvent a lot of privacy. And a couple, I mean, we've heard of Cambridge Analytica as well, and what Facebook is doing, what Google is doing. They know a lot about us from just metadata and from inference by grouping us with others. So privacy concerns, definitely dismiss them if they come up with your stakeholders, because this will erode trust like nothing else. Anonymization kind of goes with privacy concerns. A lot of times you want to be careful that your data is properly anonymized. This can also be a form of data leakage or data snooping. There are different words for it in machine learning. So you have to be really careful about it to properly scrub the data of any personally identifiable information. And then problematic applications. I recently talked about this, like face mask detection, which is like, you'd think this is a cool application, like it's a nice computer vision problem that you can do in your free time. It's a nice project. However, if you think about it, like we have seen that the people that don't wear masks don't care. Like even if there's an actual person, they're telling them to wear a mask, and that means this kind of model is not useful for this kind of application. That means this kind of model is only going to be applied at things like protests, probably peaceful protests, because like these exist. And yeah, this is only going to enforce power structures further, and people in the field will be able to tell you immediately. So if you dismiss this, perfect to erode trust further. Then discrimination. So we've recently had it so I recently learned that the Boston housing data set actually has a column in there which is just titled B, and apparently that stands for minority, or minority housing. So having that in your data set is problematic. It's not great. So yeah, you want to be careful that your model doesn't take these input variables, but also you want to be careful that it doesn't discriminate against people. There was this problem that the new Apple Card, where you could get approved immediately with machine learning, of course, and all that stuff, was used on a couple, essentially, and so man and woman, and the man had a very high credit, how do you call it? Very high credit in this card, and the woman didn't. And it was like they had the same credit scores, shared finances, everything was shared, but something in the model looked a lot like discrimination, let's say it that way. So be super careful there. And then, of course, policing. So if you work with any kind of social place, you want to be really careful. Last PyData, I had a really, really interesting conversation with someone that worked in social causes, and someone approached them to do a data science project to identify possible criminal developments, kind of like Minority Report. It sounded a lot like Minority Report, but if you talk to these institutions that do social work, we know exactly what causes criminality in these places, which is poverty. So if you send more policing in those areas, you're just going to make it worse. And all these ethical considerations are really, really important for what you're doing, and to make experts trust you and work with you. So yeah, if you want to erode trust, these are really good to dismiss. Then be super specific about your models. Stakeholders love nothing more than a detailed readout of your parameters and model size, learning rate schedules, and hours of training. Like between us, I think no one cares, actually. Like, it's such a small part of your machine learning modeling. You probably can just ignore it and talk about things people actually care about. So I want to talk about tools. And if you want to be extra confusing, take this as a signpost that you want to avoid them. If you want to explain things to people, you can definitely use these, but who would, right? So baseline models. These are existing models. So for example, in satellite data, I worked a lot with the experts that were running my model against their model and would see what happens. Interpretable models are really good too. So really compare your fancy new neural network against something that already exists, because then experts can actually understand what you're doing and how well you're actually doing in relation to what they have done. So one of the simplest baselines is the dummy classifier in scikit-learn. I love it. It's basically just what would a random or most frequent, you can put different settings, which is really awesome, classifier do, and see how it works against it. And this is one of the baseline models, but if you have like a proper baseline models from the experts, use that one. This is really good. Like, working against the baseline is very valuable. Then explainability. So we use statistical methods to explain black box models. Explainability, like using SHAP. In this case, we have these, these feature importances, and we can see how a high and a low value of a feature importance impacts our prediction. So in this data set, we're predicting the player of the year, I think. I just took that from one example on Kaggle. I have all the sources listed. I'm going to share the presentation in the Slack later. And yeah, so a high number of gold scored means that you're more likely to become player of the year. And a very low number is going to be detrimental to that. Interestingly, red and yellow on the red cards don't impact it at all. So this way you can really communicate with experts, and they can get an understanding of how your model thinks and how your model interprets the information. And that way they can really see, like, kind of sense check against their intuition that they formed over decades of working with this kind of data. This is how you build it. So we have a random forest classifier, we can fit it, and then we have 3 lines to get this nice plot. So use SHAP, it's really good. Causality. This is going beyond correlation. We know this old saying, causality is not correlation. So we have this arrow, if I eat cookies, I'm happy. And then we can take the counterfactual, which is just a fancy word of checking if the opposite is true. If I don't have cookies, I'm less happy. Since that's true, that this might actually be a causal arrow that cookies cause happiness. So in the case of MNIST, for example, we have on the very left here a 7, and then we're trying to find what we have to change about the input data, so about this image, to get a different prediction. In this case, we're getting a 9. And on the bottom, you can see the iterations of how we're approaching this kind of changed prediction. This is a little bit more involved, but you can use the library Alibi for this. You can see that we have a CNN on the top. Then we get one sample of our data. Then we create a counterfactual with our CNN, and then we use the explain function and get how certain this is. Use visualizations, so abstract information, easily digestible and intuitive. So for example, this one is from Scikit Yellowbrick, which is fantastic with its one-liners, where you can get the residuals for your models, so you can see if there is some kind of a trend in your errors in the data. Using these kind of visualizations is really valuable because it takes people out of just looking at numbers and is really good to build more trust and intuitive understanding with experts. This is how you do it. It's literally a one-liner. Check it out. Yellowbrick is a really good library for this, and it has a lot of these. Then build interactivity, because this enables stakeholders to explore data and to come to conclusions themselves. So this, for example, is Streamlit, where you can go around in a map and just play around with the data. Really, really good to build more intuitive understanding. This is the code. I'm just going to skip ahead now. And then we have to think about model validation. So experts know how difficult their data is to work with. For example, with time series, like on the left, geospatial data, spatiotemporal data, so that is correlated in space and time, and then, of course, online learning. And for time series, for example, if we do just a random split, we have the problem that our data is correlated in time. So yeah, it's not suitable because we can just interpolate our data. So what we do is we use future samples for validation. So only look into the future for these samples. Red in this case is our validation data. There's a special thing in scikit-learn for this. And
sorry, Jesper, we really ran out of time.
Sure.
And thank you very much. Thank you very much. And everybody who connected.
Hey. Hidden bonus right here. So this should have been a 30-minute talk, and unfortunately we had some technical difficulties, so I was cut off before the conclusion, and I wrote a blog post. It will be linked in the description, but let's just talk through it. Here are the 7 ways to make people not understand your machine learning project. I love building trust. So what we have to do is erode trust whenever we can. It is very easy to bulldoze in a meeting and proclaim your machine learning model will replace all existing solutions. Don't listen to decades of knowledge, and yeah, just dismiss any concerns whenever you can. That's a good starting point. Then follow it up with domain expert advice. To make people not understand, we want to avoid interacting with domain experts. It's a hassle. Domain experts have years of experience working with the exact data you're working with. They know about ethical concerns and the intricacies of your data set. So this would be clearly a time to learn. So why would we spend 30 minutes listening when we can just spend a month or 2 months wrangling the data with probably subpar results, right? Yeah, no doing that. We want to do terribly. And then, well, since our model isn't that important realistically, we actually want to put people to sleep. Like, if people are sleeping, they are much likely to ask the hard questions. So talk about all the hyperparameters, talk about that fancy, shiny, new billion parameter model that you used, trained on that fancy, huge GPU cluster for weeks. And yeah, those stats don't mean anything to anyone. So go into detail. Don't actually talk about the problem that you're solving, but just like numbers. Maybe throw in an Excel sheet. People love looking at raw numbers in tables. And yeah, then I love a good baseline model. Baseline models help ground your machine learning model in reality. Basically, it's the idea that you can compare it to something that already exists, or yeah, like existing domain solutions, or play around with a dummy classifier to make sure you're better than random, even if there is like class imbalance or something like that. And yeah, definitely avoid linear and interpretable models, because those make machine learning clearer, and we're not gonna stand for those shenanigans. And yeah, don't use visualizations or interactive dashboards. They give data scientists agency, and we're not gonna do that or make it intuitive. Like, that would be too easy. And we're not gonna use any of the amazing tools like Eli5, SHAP, Alibi, Scikit, Yellowbrick, Streamlit. They're fantastic, so throw all those away. And of course, we're not gonna do any validation. Just a random split, maybe even, and yeah, researchers and developers have made it very hard to communicate machine learning models poorly. So these are your tips to make it really, really, really bad and to make an obscure, very complex experience. So thank you for listening, and I hope you have a great day, and check out that video over there.